Hey Mzansi Coders, what's going on guys? I'm so excited for today's tutorial. So we're gonna be looking at something different today. Validate binary search tree, right? So they say given the root of a binary tree, determine if it's a valid binary search tree. So a valid binary search tree is defined as follows. The left subtree of a node contain only nodes with keys less than the node's keys, right? So the right subtree of a node contains only nodes with keys greater than the node's keys. Right? Both the left and right subtree must also be a binary search tree. So in simple terms, what they're saying is that everything that is on the left subtree must be less than the key, right? For example, in here we can see that 1 is less than 2, right? Which is correct. Then if we go to the right subtree, we can see that actually 3 is greater than 2, right? Which is also correct. So this is something that we can actually accept and say we validated this binary search tree. So we have to return a true statement. But when we look at the example number 2, we can see that actually 1 is less than 5. So this is correct on the left subtree because everything on the left subtree must be less than the key. However, when we look at the right subtree, we can see that 4 is actually less than 5 and it was supposed to be the other way around, right? Every node in the right subtree was supposed to be greater than the key. So this is incorrect. So we do not accept this binary search tree. So we have to return false. Okay. So just to be clear and give you guys, some of you guys must still be confused. So just to be clear and give you guys a good explanation. So I thought I should actually take you to whiteboard. So where I can actually drill deeper into this, right? So let's create a simple binary search tree that we can accept. So 7 will be our root. So it is going to be our key. So anything that is on the left, here we can have 4. So 4, we know that is less than 7, so it's correct. So here, it's supposed to be any, because now we branch into the right, so it's supposed to have a node that is greater than the key. So here it's supposed to be 6, right? So 6, we know that it's actually greater than 4. However, it's still less than 7 because it's still on the right, it's still on the left subtree, so to speak, okay? So anything that comes here must be less because we branch into the left now. So we can actually write 3. Okay. So now we go into the right subtree. So here we're talking about all the things. We're going to talk about all the nodes that are greater than the key. So the first one that comes to my mind is 9, right? So 9 is actually greater than 7. Then now because we go into the left, we should have something that is actually less than 9. So here we can have 8. But keep in mind that as you can see, 8 is actually greater than 7 because everything that is on the right subtree should be greater than the key. So that's why 8 should be greater than 7, which is a common mistake that we tend to make, okay? So now that we're going to branch to the right, so we should have a greater number here, greater than 9. So I'm just going to write 12, okay? So this is a binary search tree that we can actually accept, right? If we get something like this, we should definitely return true, okay? So let's take a look at the one on the right, right? So pretty much here, the mistake that we have here is 6. So we cannot accept this binary search tree because 6 is actually greater than 5. And the rule is that everything that is on the left, everything that is inside here should be less than the key, right? Should be less than the key. So now we can see that 6 is greater than the key. So we cannot accept this binary search tree, okay? On this side, we can see that this is correct because all of these nodes are greater than the key, which is 5. And can see also that 9 is actually less than 10. So this is correct, okay? So just keep in mind with that, like all the time, that we're not only looking at the node, but we also have to consider the root as we're branching out with our binary search tree. Okay, now let's jump to the code and see how we're actually going to implement this. However, I might come back to the whiteboard and just to explain to you how the code works so that you can actually understand it from the code perspective also. So the first thing that we want to do is to create a function, right? So we're going to call it validate, right? So this function will essentially take three inputs, right? So it will take the node itself, we can call it the node, and we can call left or right. Okay, I think the better name here is just to say root, because I think that's better naming. So we just have to check if root is none, then we just want to return. So this is our base, so just want to return true. Okay, then what we want to do now is to have that logic, because we know that is to have those conditions, right? So we're just gonna say root is greater than left. We know that root should be greater than left, right? You still remember that 5 is greater than 1, so we're just doing the same thing. So here we're just gonna say root should be less than right? So we know that, like I said, you know that everything that is on the right subtree is going to be greater than the root. So that's what we're doing here. Okay, then what we want to do when we're done with this, we just want to return false, right? Because here what we're gonna do is that we're gonna say if not. So this is going to be the logic for us to reject the binary search tree if it does not meet the conditions. Okay, so now we just have to return the true statement. So we're gonna do that recursively though. So we're gonna say validate. So we're just gonna take the root. So here I was actually supposed to say root.val, right? So just to be clear that here we're just taking the key, just missed that one. So here I'm just gonna recursively go to the left side, right? Then I'm just gonna give it the left value. Then here I'm just gonna give it the right, the value that we just passed in. Okay, so I will explain all of this more clearly. So now let's do the same thing for the right subtree. So here we're just gonna pass in root.right, and we're gonna pass in the, because now we're gonna have to validate the root val if it's less than right. So what we wanna do here is that we wanna pass in the root val here. Then here we're just gonna provide right. Okay, I hope I did not miss anything. Okay, I think everything is fine. So let's go and return our function. Return validate. We're just gonna take the root, right? And here we're just gonna return float of infinity, negative infinity. That is the left side. And here we're gonna return infinity. Okay, I think we're good to go. Let me just submit and see if I did not make any mistake. Oh, I see that I made a mistake here. Typo on the false. Perfect. So we got the success, right? But I think I did not do a good job explaining this part here. And so let's go to the whiteboard and I want to explain that part. So that it's clear to you. Okay, now let's look at the explanation of how we kind of like recursively going through this, right, during the code. So in simple terms, the only thing that we're doing essentially is you can think of this as a range, right? So we're just updating the range because of you saw that the first thing that I did was to give my left negative infinity and to give my right a positive infinity. Why did I do this? Because we know that on the left, when the key should always be greater than anything on the left, right? So we don't know what's on the left when we start with our code. So we can just say negative infinity. So similarly on the right subtree, we just don't know what's there. But one thing that we know is that all the nodes should be greater than the key, right? So meaning that the key should be less and everything on the right should be greater, right? So key less than right. That's one thing we know. So how about then these right here? Then we just say it's positive infinity, right? And here on the left, we can say negative infinity. Then we just update these values, right? So how do we do that? So let's take a good example here. So the first thing that we're going to do is that we're going to ask 4 is greater than infinity, right? So because we know that it has to be greater than negative infinity and it should be less than 7, right? So 4 should be greater than infinity, right? Let me just write it here, and it should be less than 7. That's the condition that it should meet. Then when you go here, you're also doing the same thing. You're just updating the range. So you're just saying is 3 great, because of here is the last node. So you're just gonna say is 3 less than 4 and less than 7, right? That's what you should be doing. You're just updating the range of the values. So you just have to keep track of these values here. But whenever you start, you just start with negative infinity because we don't know the left or right values. But because of we know the condition, we are confident to say let it be negative infinity and positive infinity.